Hello there, everybody. This video is about the law of sines. Up until this point, we have been working with right triangles, finding missing angles and sides in right triangles almost exclusively. We haven't really addressed how to find missing sides and angles in non-right triangles. So that's what this video is going to be about. How to find, or one way anyway, to find missing sides and angles in non-right triangles. One of those ways is called the law of sines, and you see it here. I'm going to let you, if you're interested, you can look up online how this comes about. But for now, just know that the sine of the angle A over the side A equals the sine of the angle B over the side B. So sine A over A, sine B over B. The angles are on top with the sines. Notice we got the angles labeled with capital letters. The lowercase letters are the sides. A couple things to remember. This side and this angle they have to be opposite one another. Same with this side and this angle. The side and the angle that's in the same fraction, okay, big B and little b, they have to be opposite one another in the triangle. That's very, very important. If you don't set it up like that, you're not going to get it right. So let's take a look at an example. So here is a triangle. We know two angles, 40 and 34 degrees. We know two sides, 10 and x. Now the 40 degrees and the x are opposite one another. So we can go sine of 40 degrees over x. And the 34 and the 10 are opposite one another too. So we'll go equals sine of 34 degrees over 10. Now we've got a proportion that we can solve. We solve proportions by cross multiplying. So we'll go x times the sine of 34 degrees. Now you could, at this point, you could use your calculator to figure out what the sine of 34 is and put a decimal here. And the sine of 40 is and put a decimal here. If you do that, you're going to be cutting off decimals. You're going to be not writing down some of the decimals in sine of 34 and sine of 40. And if you do math with approximate answers or approximate values for these, okay, and do this cross multiplying with those approximate values, your answer is going to be off a little bit. I would really, really encourage you to not do the sine of these angles until the very end of the problem. And that's what I'm going to show you how to do here. So cross multiply, x times sine of 34, that's got to be equal to 10 times the sine of 40. Now remember, sine of 34 degrees, that is just a number. That's multiplied by x. So you undo multiplication by dividing. So we're going to divide by the sine of 34 degrees. Divide by the sine of 34 degrees. Those sine 34s, they cancel. And we get x equals all this stuff. Now's the time I'm going to put that into my calculator. So let's see, here we go. I'm going to make sure I'm in degree mode. This is probably easier in your, yeah, I am in degree mode there. So I'm good. Now I want to do 10 times the sine of 40 degrees. There, and I want to divide that by the sine of 34 degrees. And it's going to spit out an answer of about, I'll change that to about 11 point, we'll say 49. I'll go one digit more than I usually do here. And so there is the length of this missing side. Now one way you can check your answer on these, in these non-right triangles, notice that 40 is bigger than 34. That means the side opposite the 40 degrees, opposite the bigger angle, should be bigger than the angle or the side that's opposite the 34. So 40 is the bigger angle. That means the side opposite 40 should be bigger than the side opposite the 34. And we got a number that's bigger than 10. So we know our answer, at least approximately, is correct. So let's go on to another one. Okay, So here's another triangle. The 8 and the 100 are opposite each other. So sine of 100 degrees over 8. Now, the x is opposite that angle, which we don't know. Oh, but we know that the angles in a triangle have to add up to 180. So we know two of them. That means we can take these two away from 180 to get this one. So 180 minus 100 minus 25 is 55 degrees. Now the 55 degrees and the x are opposite one another. So 55 is what we got to use in our equation here. So sine of 55 degrees over x. Angle on top, side on the bottom. And there we go. Now we do the same thing. X times sine of 100 equals 8 times the sine of 55 degrees. Now remember, sine of 100 is just a number, and it's multiplied by the x. We've got to undo that multiplication, so we're going to divide both sides by sine of 100. Sine of 100 degrees. Now those sine of 100s, they cancel, and we're left with x is approximately equal to all that stuff. Okay, so now we go to our calculator. We'll go 8 times the sine of 55 divided by the sine of 100. And we get about 6.65 as our answer. Now, just for the heck of it, let's double check. 100 degrees is the biggest angle. That means the side opposite that has got to be the biggest side. So 8 should be biggest. Now, we got about 6.65, and 8 is bigger than that, so we know at least approximately, we're in the ballpark of the right answer. And in fact, we did do all of our work right. This is the actual length of that side. Hope that makes sense. Good luck on the practice. Get some help if you need it. Bye.